Well, here's a practical use of some math. A farmer needs to build a rectangular pen along the side of a 50-foot barn. So basically, this is going to be the barn. And let's say that, I don't know, this is the barn. But it is 50 feet across. Okay, so that's the barn that already exists. And then the farmer needs to make a rectangular pen. So the farmer could build the pen so that it's a rectangle that goes like this and basically uses part of the barn so that they could save money and not have to build any red fence right there. All right. The next thing is there's 250 feet of fencing material. So right now, I don't know how wide or how long this is going to be. So I could say that this side is X, and this side is X, and this side is Y. And then maximize area. Well, area of a rectangle, you just multiply the two sides. So area will be X times Y. That's part of it. To find the maximum, well, that means that eventually we're going to have a parabola, and the vertex is going to tell us where the maximum occurs. But a equals x times y, that is not a parabola, so there's more work to be done. Also, I haven't used the 250 yet. So basically, I need to add up all of the red parts, and that has to equal 250. So I know this side is x, this side is y, x, this side is y, and then what about this red part? Well, going all the way across, that would be y, but they don't have to build this part, so there's 50 feet that they don't have to build on that side because of the barn. So that means instead of this question mark, that's going to be y, but you can take off 50 feet. All right. Now, when you add up all four sides, that has to equal 250. So there's an x plus an x, so that's 2x, plus the y at the bottom, plus the y minus 50 at the top, and all of that has to equal 250 feet of fencing. I can then use this to find out what y equals, and when I do, I'll substitute it into that function for the y. Well, let's see. There's 2x plus, there's 2 y's, and then I could add 50 to both sides. So that means that it equals 250 plus 50 is 300. I could even simplify things by dividing everything by 2, which means x plus y will equal 150. And then I could solve for y, so subtract x on both sides, and y will equal 150 minus x. And then that is what I'm going to substitute for the y in the area formula. So I get area equals x times y, but then y can be replaced with 150 minus x. And that is a quadratic formula, because if you multiply it out, this is going to be negative x squared. So that means that it is a parabola that looks like this, as I had promised. And then we just need to find the vertex, because that's where the maximum is. Well, there's several ways to do it. One way to do it is find out where these red dots are. In other words, where the function equals 0. And then the vertex, because the graph is symmetric, the vertex will be right in the middle. So those red dots means set it equal to 0 and then solve for x. And usually I would multiply it out, but this is already factored for us. And when it's factored and set equal to 0, then you just set each factor equal to 0 separately. It's called the zero factor property. So one answer is x equals 0. And for the second one, you could just move the x to the other side. It'll become a positive x equals 150. So this red dot is when area equals 0. And this is when area equals 150. And then what's in the middle of a 0 and a 150? Well, you can just add them together and divide by 2. And then 150 divided by 2 is 75. So this is 75. And because we were working with x, that means x equals 75. And so I think I could just put it right here, my final answer. So x equals 75. And then if you substitute the 75 in for x, it's going to say y equals 150 minus 75, which is 75. So 75 feet by 75 feet. So the rectangle is actually a square.